In this video, we're going to be talking about factoring completely, so using a general strategy for our factoring. The first step you're always going to do is look for GCF. This is the number one most forgotten step. So is there anything that all of your terms have in common? Look for that first. Then, if you've factored it out or there's nothing left to factor out, we count the number of terms, okay, so not including the GCF. And if there's 4 terms, we're going to factor by grouping. If there's 3 terms, we have to decide if that front or the leading coefficient has a 1 or if it's not 1. If it's 1, we find those factors, so the 2 factors that will multiply to give us A times C and add to give us B, and we can directly plug it in. If it's not a 1, then we still have to find those factors that multiply to give us A times C and add to B, but instead of plugging it directly in, we have to rewrite that middle term using the factors we found. And then we'll have 4 terms and we'll factor by grouping. If there's 2 terms, we have to ask ourselves, is it the sum or difference of cubes? Is it the difference of squares? You actually always need to ask yourself this one first. I apologize that it's out of order on your paper, but the difference of squares needs to come first, and then ask yourself, is it a sum or difference of cubes? So the square first, and then the cube. And if it's a sum of squares, then that's not factorable. So sum or difference of cubes is factorable, only the difference of squares is factorable, not the sum of squares. And then we have to ask ourselves again, is anything else factorable? So even after we've factored, it's possible that something we factored can be factored further. Alright, so let's try some of these. This first one, we look for GCF first. So this has a coefficient of 1, so there's no GCF for the coefficients. This has A and X. This has a C and X. This does not have any X's, so there's no GCF. That's always our first question. So no GCF. Then we count the number of terms. 1, 2, 3, 4. So as soon as I see 4, I'm going to factor by grouping. So I'm going to group these together. I look for the GCF on the first 2 terms, and I notice they both have an X in common. I look for the GCF on the second 2 terms, and I notice we both have a 3 and a Y in common. So I go ahead and I factor out that GCF. I get A minus 3C. Right, I should be able to distribute and check myself. And then I take out my other GCF of 3Y. I'm left with A minus 9 divided by 3 is 3. The Y's divide out and I have a C. If I did this right, then those 2 terms that I just factored should match. Okay? So now that's the GCF as a common factor now. It's being multiplied and I can take it out. So when I take out that A minus 3C, I look at what's left. I have an X and a positive 3Y. And that's as far as you can go. Again, I check what's left of what I factored, and there's no perfect squares, no cubes, anything like that. Since they're both 2 terms, that's as far as I can go. Alright, let's look at this next example here. GCF comes first. So I notice that they're both even, so for sure 2. And when I take a 2 out, so GCF first, I would be left with 81x to the 8th minus 16y to the 4th. Alright, so GCF is done. I count my number of terms. I have 1, 2. I ask myself, is it a difference of squares? So the difference of squares needs to come first. And 81 is a perfect square. X to the 8th, that exponent is even, so that's a perfect square. 16 is a perfect square, and y to the fourth, that's a perfect square. So I have to factor in my difference of squares. And I ask myself, what times itself would give me 81? That'd be 9. Or take the square root and get 9. And then what times itself would give me x to the 8? I can just take that 8 and divide it by 2. So I want something times itself. So it must be x to the fourth. Right? X to the fourth times x to the fourth would give me x to the 8. Then I know that these are going to be conjugates because of my rule for the difference of squares. So one is plus and one is minus. I do the same thing with the 16y to the fourth. Square root of 16 is 4. And y squared times y squared would give me y to the fourth. Right? I just take this exponent and divide it by 2. And then I stop and I reevaluate. Is there anything else I can do? So I took out my GCF. These are squares. They're all perfect squares, but it's a sum, so that's not factorable. And over here I have perfect squares, right? 9 and 4. These are even exponents. They're all perfect squares, and it is a difference. So I need to keep going. So I leave the 2 alone. I leave the sum of squares alone. That is not factorable. But this piece is now. Let me go ahead and get a different color here. So this piece here is factorable. It is a difference of squares again. So what times itself would give me 9? 3 times 3. Take my x to the fourth, divide the 4 by 2. So the x squared times x squared. They're conjugates, so I do the plus and the minus. And then take the square root of 4, I get 2. And then y times y would give me y squared. And now this whole thing all together is completely factored. Right? Because I would double check again, but there's no perfect squares anymore. So this is as far as I can go. There's no cubes. That's it. So as soon as you get done factoring, you have to check again. Is there anything else that I can factor? Alright, let's look at this one more on the left here. I have 15x squared minus 11xy minus 14y squared. Start with the GCF. I do not see anything in common. Count the number of terms. 1, 2, 3. So that means I have to check. My front coefficient is not 1, so I have to multiply a times c. So 15 times negative 14 is negative 210. And I want it to add to negative 11. So I'm looking for factors of 210 that add to negative 11. Well, the most obvious one to me is this ends in a 0, so 21 and 10 would multiply to give us negative 210. Well, give us 210, and then we have to decide where the negative would go. If I put the negative with the 21, negative 21 plus 10 gives me the negative 11 that I need. So now, because this front coefficient was not 1, I do not go into my parentheses. I have to break up that middle term. So negative 15x squared, and instead of writing negative 11xy, I'm going to write minus 21xy plus 10xy. Those will add up to negative 11xy. And then my last term stays the same. Now I have 1, 2, 3, 4, and I have to group. So I'm grouping the first 2 terms and the last 2 terms. And I plot my GCF for the first 2. So 15x squared, 21xy, they both have a 3 in common and an x. The GCF for the next 2, 10xy, negative 14xy squared, they both have a 2 in common and a y. So now I divide out those GCFs, I'd be left with 15x squared divided by 3x is 5x, and then negative 21xy divided by 3x would be negative 7y. Right? The x's divide out. Then over here, I'm taking out a positive 2y. 10xy divided by 2y would be positive 5x. And negative 14y squared divided by 2y would be negative 7y. Again, if I did this the right way, then these two terms should match. And they do. So that's the GCF. I'll take out that 5x minus 7y, and look at what's left. I'm left with a 3x and a positive 2y. And there's no more perfect squares or cubes or anything like that, so that's as far as we can go. Go ahead and try all the ones on the right here. Alright, now I'm looking at 36e to the 5th minus 4e. I always start with my GCF. And I decide that they both have a 4 in common and an e. I'm going to take out a 4e. When I divide that out, I would be left with 9e to the 4th. Right? I had 5, I took 1 out. Minus 4e divided by 4e is 1. So a lot of times I see students stop here. You have to ask yourself, am I done? Is there anything else left I can do? So I have two terms. I start with, are they a difference of squares? 9 is a perfect square, e to the 4th is a perfect square, and 1 is a perfect square. So I have to keep going. What times itself would give me 9e to the 4th? 3e squared, right? 3 times 3 is 9. E squared times e squared is e to the 4th. These are conjugates, so one is positive and one is negative. And then 1 times 1 gives me 1. And now e squared and 1 are perfect squares here, but 3 is not. So that's as far as we can go. Alright, let's look at another one. GCF first. In this case, I see they're all even, so 2, and they all have at least one p. So I can take out 2p. What's left when I take that out? 2 divided by 2 is 1. P cubed divided by p would leave me with p squared. And then same thing, 2 divided by 2 is 1. And then p squared divided by p would just be 1p. And 84 divided by 2 would be a negative 42. And p divided by p divides out. Totally, there's no more p's. Alright, so I took out my GCF. I count the number of terms. 1, 2, 3. Trinomial. And that first coefficient, the leading coefficient, is 1. So I just need factors of negative 42 that will add to negative 1. Negative 42. I'm thinking 6 and 7. And one of them has to be negative to multiply to a negative. And I need the bigger one to be negative if it's also going to add to a negative. So again, since that front coefficient is 1, I can go right into p plus 6, which is that factor I found, and p minus 7. And that's as far as we can go. Again, that only works if the front or the leading coefficient is 1. Alright, this next one. I see I've got 1, 2, 3, 4 terms. There's nothing that's in common with all of them, so I'm going to group them. And use a different color. GCF from the first group, for the coefficients, they both have a 4 in common, and for the variables, an a squared. For the second group, they both have a 5 in common and no variable. So divide out my GCF. What's left? 12 divided by 4 is 3. A cubed divided by a squared is a. 8 divided by 4 is 2. And a squared divided by a squared is 1. Same thing over here. I'm taking out a positive 5. So 15a divided by 5 would be 3a. And 10 divided by 5 would be positive 2. If I did it correctly, those should match. And they do. So now the GCF is 3a plus 2. What's left when I divide those out? 4a squared plus 5. And there you go. Alright, let's try another color for the next one. Alright, so now I look for GCF, I don't see one. I count the number of terms. 1, 2. 2 terms. The first thing I ask is, are they a difference of squares? Yes, 61 is a perfect, 61 is a perfect square. These are even exponents, so those are perfect squares. So I'm going to break it into my 2 difference of squares. What times itself would give me 64? 8. 8 times 8. And then remember to find out what times itself would give me x to the 6th. We take the 6th and divide it by 2. So x cubed times x cubed. Same thing, I need my conjugates here, or the part that makes these conjugates, the plus and minus. And I'm breaking up y to the 6th into y cubed times y cubed. Again, these are squares. I just take 6 and divide by 2. Alright, so now I'm here, and I ask myself again, is there anything else I can do? Well, 8 is a perfect cube. X cubed and y cubed are perfect cubes. So these are both sums and differences of cubes. So we have to factor both of these again. So let me go ahead and use a different color. Alright, so when we factor a sum or difference of cubes, we have to figure out what is being cubed. So what times itself 3 times would give me 8? That is 2. 2 times 2 times 2. And what times itself 3 times would give me x cubed? X. X times x times x would give me x cubed. Then we have the same sign. Remember, we're going to use that SOAP acronym to remember the signs. So same sign. And then what times itself 3 times would give me y cubed? Y. And then we go into the squares and things. So 2x times 2x will be 4x squared. Multiply these two things together, making sure to use the opposite sign. And 2x times y would be 2xy. And then always positive sign. And y times y, which would be y squared. So that's just this first one. Now you need to do the other one. So now I'm doing the difference of cubes. The good news is, since these have the same values here, they are conjugates, everything except for the sign. Everything except for the sign of these is going to be the same too. So 2x cubed would give me 8x cubed. Or, yeah, 2x, that whole quantity cubed, would give me 8x cubed. Now the same sign would be a minus in the middle, and y times itself 3 times, give me y cubed. Then 2x times 2x is still 4x squared. I need the opposite sign. Then 2x times y is 2xy. And then always positive sign. And y times y is y squared. And phew, that whole thing is now totally factored. That is as far as we can go. So difference of squares first, and then look for difference of cubes. Alright, one more here. We have 4c squared minus 16cd plus 15d squared. Okay, so I don't see a GCF. These, the front coefficient, oh sorry, there's 3 terms here, and the front coefficient is not 1. So I do a times c, and I get 60. And I want them to add up to negative 16. So I'm thinking 6 and 10. And if they're going to multiply to a positive, they either have to both be positive or both be negative. But since I need them to add to a negative, they have to both be negative. So 2 negatives multiplying give a positive. Negative 16 plus negative 10 gives me the negative 16. So, since the front coefficient is not 1, I am simply rewriting the middle term as negative 6cd and negative 10cd. Okay, we're just rewriting this. And then the last term stays the same for now. So now I have 1, 2, 3, 4 terms. I'm going to group. So group my first 2. The last 2, I'll look for a GCF. I think the GCF of 4 and 6 will be 2, and they also both have a c in common. So what's left when I divide that out? 2c minus 3d. Right? 6 divided by 2 is 3. The c's divide out. I still have a d. Looking at these next 2, I notice that the signs in the first 2 go plus minus, and the second 2 go minus plus. So I'm going to have to take out a negative as well. And then the GCF for 10 and 15 will be 5, and they both have a d that I'm going to take out. When I divide out negative 10 divided by negative 5, I get a positive 2. The d's divide out, I still have a c. Positive 15 divided by negative 5 will be negative 3. And then one of the d's divide out, I still have another. Now, these, again, if I did it correctly, the 2 factors left over should match. So I'm going to take out that 2c minus 3d. When I divide that out, I'm left with 2c minus 5d. And that's as far as we can go. So again, the steps are GCF, count the number of terms, and then use the proper factoring for those number of terms, and then check again to see if there's anything else you can factor.